In this video, I want to define a set and talk about different operations that we can perform on sets. A set is just a collection of objects, and these objects can be anything. One example of a set would be an event that we had talked about in the previous video. We can also use Venn diagrams to help illustrate and visualize sets. The first operation I want to look at on sets is the union. And if I have two sets A and B, we do the union by this U symbol. A union B consists of all the outcomes that make up events A and B. Let's consider the Venn diagram. Here I have my set A and my set B. The union would be everything that makes up A and everything that makes up B. So it would be essentially combining these two sets. I would look at everything in A as well as everything in B. The next operation is an intersection. And this time, if we have two sets, we use this upside down U symbol, so it's essentially the upside down of the union symbol, to mean A intersect B. The intersection consists of all outcomes that are common to the events A and B. So it's what they share, what they have in common. To look at the Venn diagram, here I have my A circle and my B circle. The intersection would be the piece that they share, this overlapping of the two circles. So this would represent the intersection of A and B. Next, we have the complement. The complement of a set A is denoted by A with a little c as an exponent. The complement of a set A consists of all the outcomes that are not in A. It's essentially the opposite of A. Here I only have a single event, event A, so I only have one circle. And the complement would be everything that's not this circle, so the rest of the box. This would represent the complement, everything that is not A. The last operation I want to consider is the difference. It's denoted by A minus B. The difference A minus B consists of all the elements that are in A, but not in B. For my Venn diagram, here I have my sets A and B. A minus B would be everything in A that's not in B. So almost all of A except that we take out this overlapping area. So this would be the difference A minus B. Next, I want to define mutually exclusive, also known as disjoint. We say two sets are mutually exclusive or disjoint if they have no events in common. Another way to say this is that A intersect B is equal to the empty set. So they don't share anything in common. Here's a Venn diagram for mutually exclusive sets. They don't overlap at all since they don't share anything. They don't have anything in common with each other. The next definition I want to look at before I start doing examples is that of a subset. This means that all the outcomes in A are also outcomes of B. So essentially, A is kind of contained inside of B. Here's a Venn diagram representing this. We have our circle that represents B, and then A is completely contained inside. One other quick notational thing. I want to look at this notation here. We have X, a little symbol, and then A. This means X is an element of A, or X is contained in A. So if I want to talk about a single object inside of a set, we can use this symbol to denote that this element here, X, is contained inside of this set A. Now that we've got all of the definitions, let's start to look at some examples of each of these operations. So I'm going to consider the case where we're rolling a standard six-sided die. I have an event A that consists of rolling a 1, 2, and 3, an event B that consists of rolling a 2, 4, or 6. So I want to know what the union is. The union, A union B, means we're essentially going to combine these. A consists of 1, 2, and 3. B consists of 2, which we've already included, 4, and 6. So the union 1, 2, 3, 4, 6. What about the intersection of these same two sets? The intersection is what they have in common. And looking through these, the only thing they have in common is a 2. So A intersect B would just be 2. Now let's look at A minus B. This time we want everything in A that's not also in B. So 1 is in A, but not B. 2 is in both, so we don't want to include that. And 3 is in A, but not B. So A minus B would consist of 1 and 3. Now I have 3 different sets. A is 1, 3, 5, B 2, 4, 6, and C is 2, 4. I want to know which ones are mutually exclusive. So remember, mutually exclusive means they have nothing in common. Well, we can see that A and B have nothing in common. Since A consists of all odd numbers, B has all even numbers. In addition, A and C have nothing in common. So A and B are mutually exclusive and A and C are mutually exclusive. However, B and C do have things in common, so they would not be mutually exclusive. Which one of these sets are subsets? So a subset means it's completely contained inside. Well, C is a subset of B since everything in C is also in B. B is not a subset of C since B contains 6 and C doesn't, but we can see that C, everything in C is also in B, so C is a subset of B.